Hey guys, welcome to part 2 of a photogrammetry scanner build. Today I will design the holder for the motor. So if you remember from the previous video, we will basically have a I want to have a mount for a tripod where I can have a NEMA 17 stepper motor, and on that motor I can just place a plate and I can place whatever I want to scan on that. So I want to have a holder for this motor that I can screw onto the tripod, basically. So I don't have the motor here right now because that's in my studio in another town. I have to go get it, but I wanted to get started here. But I do actually have, so we have the empty plasticity scene here, and I will of course do this design in plasticity. But if I now import, go to desktop, and I have here a NEMA 17 CAD model, and I just want to make sure that this is in the correct size. So let's see if I just do like that. Oh, it's not. So I can just re-import that and make it centimeter instead. And now this should be having the correct size, and that is 42 millimeters. That is correct. So if I go to top view now, and so this is centered, which is really nice. So if I just create a rectangle, click C. You see down here to the right, you have a few hotkeys. So square, C for center, and K for knife. I click C, and now it gets centered. And actually, I want this to be square as well, so I can do that. Now, either I can just eyeball this, or I can hit Tab, and I can enter the exact values that I want. Now, this motor is, if I am correct about things, this is precisely 42 millimeters. And actually seems to be 42 and a half. Not really sure. I really should have the motor here to make measurements, but I know that this CAD model is correct, so it shouldn't be any problem. Actually, let me just add so 42.4. Let's make this 42.6, because usually you have 0.1 millimeters of you have to add that to get your tolerances right. So we can just test that. And now I want to make another one, center and square, and we can make that a little bit bigger. I don't really have to care too much about the measurements here, but I think, this will be just fine. It doesn't have to be super sturdy either. So if I take these now, and I can just do like this. Actually, you know what? Maybe I should actually make this just a little bit bigger. Something like that. I'll print this and we'll just see how it works. And then we can round this off, make it look a little bit better. And now we can pull this up to just as far as we want it. So somewhere around there, I guess. Then of course we can pull this. You know what we can do? We can skip that. We can just take this one and pull this down quite a bit, actually, because I want the screw here. So what do we have here? So let's make that 10 millimeters. All right. And if we now if we hide this, you can see here that somewhere along this, oh, actually I don't have, okay, I really need the model, shit. I actually found a stepper motor. So this is the one we'll be using. And there's a few, so what I want to do basically, I want to have, this is the Manfrotto quick release plate. I want that attached underneath here so that we can just set this on any tripod. And also, to be able to do that, by the way, I do have these, if that can focus. No, didn't want to focus. Okay, there it is. So these are come on. These are brass inserts. So they are So they have these threads, and this is for the 1/4 inch or whatever. This is the normal tripod mount. So basically, I can screw this onto here, if that makes sense. And the thing with this is that you put this on your soldering pen, and then you can just push it into your 3D print, and it will basically be like welded into your print. And I also have another thing. That is these. And this is something I got from Amazon, which are just simple, these bubble indicators. Oh my god, the software for this camera is shit. Anyway, you'll see it better later on. So I have to account for that as well. So the thing is, I just want to, first of all, take some measurements here to make sure that I'm in the right ballpark. So the width of this NEMA motor is 42.26. So that means that if I measure from here to here, actually, if you do like this, if I just measure from here to here, come on. No. Jesus. Okay, there we go. So 42.76, 42.25. I could actually make this a little bit less, a little bit smaller. So if I offset this, so 42 point, what was it? 40, no, it's 41 point, okay, 941. There's a bit bigger, 42.15. So 42 point, okay, I think something like that should be fine. But so this is not actually perfectly square. This is 41.8 in one side and 42. Depends a bit where I'm measuring. They should be perfect square. Anyway, another thing we also have to care for is the cable. Like I want to slide this into this holder, but I also want to make sure that I can bring the cable. And yeah, we'll see how we fix that. So if I just take a measurement here, so the cable, what I need for that is maybe 7 millimeters. So what we can do is just to center, make this 7 millimeters and cut that off. So I think that will be perfectly fine. we won't have any stability issues anyway. Then for this down here, so we need to make sure that we have enough depth. This is 12.7 millimeters, and I made this 10, so I have to increase that quite a bit, to be honest. Maybe add 5 millimeters there, and that should be fine. And also the width of this is, so the width of if we measure the outside here of these threads, that will give us an incorrect result. So I have to measure like the thinnest part, and that is 7.3. So maybe, yeah, if I make that 7.3, I think that'll be good. So 7.3 millimeters, and we can just take that and pull it down like this. And so like this, and use Q to cut, or Boolean. So I know I was quick now. I didn't actually think about that. So if I hide this, I can hide this one as well. So all I'm doing is, I have this cylinder here now. Click this one, Q, click that one, and then I get a hole. And that is great. Actually, though, what I want to do, if I click V, and I can set my pivot point wherever I want to, and I can then hold control and snap that to this surface. Now I know that this was 12.7, so I want to move this up 12.7, and by doing that I know that I cannot push this too far through when I'm pushing it in. So that's a thing to think about. So I don't want the hole going all the way through. So now we should be pretty much prepared for that. If I can unhide everything, and this one can attach with this one. And I think for the design, just design-wise, I think we can, you know, see if we can just make this a little bit nicer to watch. Maybe if we take that one first. What happens if we... Oh yeah, we can do that. That'd be looking good. We can actually do the same thing here, just to have a little, just a little rounding off. So this will be good, and I hope this will be tight. If it's not tight enough, we can just add a bit of glue in the bottom or something, so you know it holds this motor in place. But I think this will be quite tight. Actually, I do want to, because I want this to be really tight. I just realized. So let me push this in to make it 42 point, something like that instead. 42.16. All right, and there's one more thing, and that is this little bubble. So if I measure that, this is 14.8. So if I make a little sphere here that is 14.95 maybe, I hope that'll be enough. And then I can make a duplicate of that and scale it up. And then what if we take both of these? I just want to make this looking nice now. And then I take this one and this one. And so where do we have tangency here? We have tangency that is there. And we have tangency there as well. So if I would cut that off now, but I actually want to make this a little designed. Just Shift B. Come on, okay, stupid me. You know, we can just take this one and Shift B as well to bridge those. And now we can take this one. And how thick is this? By the way, we can, by the way, just pull this up. Let's make that 2 millimeters first. And okay, let's just move that up there, and we can just pull this up. And this one, let's make this now. I want to extrude it. So that is 8 millimeters plus add 1. So let's make that 9 millimeters. And then we can cut that off, and then we can add a little rounding here. Just something like that. And now we can just attach these two with Q to boolean them together. And then maybe we can add a little nice fancy design there. And a little nice fancy design here. I think this looks quite cool. Hopefully this will be looking good. I think we're done. So now we will have attachment for the quick plate. We will have the bubble. We have the holder for the NEMA motor here. And this will be good. This will be great. So now I want to print this. So let's just save this. Viz Guru. Let me just... So here I have a folder where I can save this, and I want one that is called hardware, one that is called software, and here I can just this is called this, yeah, let's just portable photogrammetry scanner. NEMA 17 mount. All right. Then I'll export this. I'll go into Bamboo here. And we can print this without any supports. I won't be using supports, but we can turn it off anyway. This will take 1 hour, 20 minutes, 42 grams of plastic. That is great. And I hope this will work just fine. So let's print this now and see what happens. I just got home from a board game session with a few friends. It is 12:30, but I thought, hey, I just want to finish this video. So here we got the print. Focus. Anyway, fuck it. And I think this works pretty well. So if I put this in here, I have to use some force to get it in. And that is exactly what I wanted. And look at that. It just fits so well. It sits, I mean, wow. We nailed this. And now this thing. So if I take one of these and just put that here basically and try to push it down. Maybe I need a plier or something to get that down there. Actually, I didn't. So now that is there. So now if we put this on a tripod now, where are we? There we are. Come on, focus. So now, you know, we have this bubble there. So when we put this on the tripod, we can make sure that the table is straight. And these are like, I don't know, a few cents each from Amazon. So I don't think they're like very reliable, but it's better than nothing. And I mean, even if they're not like super reliable, it's still at least, you know, knowing somewhat if it's straight or not. So the only thing that is missing now are these that's going down in here. And you know what? Let's just do it. All right, now it's hot as fuck. So let's see if this works. I'm not really sure which end. Actually, I think I have to flip it actually. So maybe like this. I cannot touch it now, obviously. So let's try this now. If I can get this in there. Maybe I made the hole a little bit too small. But there it's in. It's in all the way. Alright, let's just let that sit for a little bit. Alright, this has cooled off. I didn't get it perfectly straight, but I think this should be just fine. So now I can take this quick plate, and I don't know how much force I can pull with this. I'm not going to use excessive force, obviously, but there, you know, this sits nice and tightly, more than enough. And then I have this, of course. So this I will put on the tripod, and now I can just click this in like this, and voila, my motor sits nicely and firmly. Maybe I should pull this a little bit harder. I can actually hear like the plastic cracking there, so I'm not really sure how. But this is well more than enough. Looking good. All right. So now this piece is pretty much done. Of course, I need to print. I need some ideas later for some kind of table here where I can put whatever I'm scanning. But for now, I consider this part done. I'm actually having another motor as well, so I'm gonna print one more to make a double of this. Maybe if I can sell one of these scanners, or just have one in reserve, or I don't know. Maybe someone wants it and I'll just give it away. So yeah, that's it. In the next video, I think we will be. I'm not really sure what I will do. Yeah, we'll see. We'll see.